Okay, so here we talk about linear equations in standard form, and this is one of the topics discussed in 2.4. So generally, a linear equation in standard form is the equation that appears in the form ax plus by equals c. The whole idea is it's an equation, so x and y are the variables of the equation. So the capital A is the coefficients in front of the x variable, and capital B is the coefficient in front of the y variable, and c is another coefficient on the other side of the equation. And so here once again the general form of a linear equation in standard form is ax plus by equals c. So we call this equation in this form a standard form. So now quick examples would be, so you might have something like this: 2x minus 3y equals 5, or you have x plus y equals 1. So these are all quick example of linear equations in standard form. The point, so once again in part A of the example, you can see that the coefficient A would be 2, and the coefficient B would be minus 3, and C would be 5. In example B, the coefficient in front of the x the coefficient A would be 1, coefficient for B would be plus 1, and coefficient C would be positive 1. So now we're getting into how to graph a. Generally, we graph linear equation in standard form. We generally graph by plotting the intercepts. So that's the main technique for graphing any linear equation in standard form. So the point here is that if you imagine here's the x and y axis, and suppose the linear equation is going to give some line, then that line is going to intersect. The intercepts are basically those points where the graph is crossing the x and the y axis. And so here the crossing point between the graph and the x-axis, we call that point the x-intercept. And so the coordinates, as you can see, the coordinates is always it has some a value, right? So it has a comma 0 coordinates. So what you're seeing here, the reason we have a 0 coordinates for y is because you can see that the crossing point is sitting right on the x-axis, meaning we have 0 coordinates for y. Now on the other hand, the crossing point between the graph and the y-axis has coordinates 0 comma some b value, and we call that point the y-intercept. So generally we can graph any linear equation in standard form by just simply looking for the two intercepts and plot the two intercepts on the appropriate axis and connect the line, and that's how we can get the graph. And so here's how it works. So if we now looking at example number 1 here. By the way, maybe let's do something different first. So if we look at example number 1, we would like to graph the equations 5x plus 2y equals 20. Okay, and so this equations here, what I have here is a linear equations. The coefficient A is 5, the coefficient B is 2, and the coefficient C is 20. So to graph this, construct for yourself a quick small table. One column on the left is for the x variable, and one column for the y on the right hand side is for the y variable. And so to plot the intercept, to find the intercepts, what you need to do, first of all, I'm going to let x be equal to 0. Here we're trying to find the y-intercept. Because remember, to find the y-intercept, we always start out solving the equation by letting x equal 0. So now, setting x equals 0, the equations is going to become 5 times 0 substituted for x plus 2 times y equals 20. And now I'm going to solve for the corresponding y value. I'm going to solve for the y values corresponding to the value x equals 0. So this equation would become 5 times 0 equals 0. So basically we have 2y equals 20. And so dividing both sides by 2, which is the coefficient in front of the y variable, we're going to have y equals 10. So my first intercept would be x equals 0 that we chose, and y would be computed to be 10 according to x equals 0. So now on the other hand, we're going to start out by letting y equals 0, and doing this we're trying to find, by letting y equals 0, on the other hand we're trying to find the x-intercept. Okay, and so for the x-intercept, once again we start by letting y equals 0. I'm plugging the value of y into the equation, so my equation would become 5x plus 2 times 0 substituted for y equals 20. And so that would become, so the equation is going to become 5x equals 20, dividing both sides by 5. That gives me x equals 4. So x equals 4 is the x value corresponding to y equals 0. So now I'm going to fill in my chart by putting y equals 0 that we chose into the place of the table, and now correspondingly my x equals 4. So here's how I put it in. So meaning I have these 2 points. One point to be put on the graph is the point 0, 10, and the other point is going to be the point 4, 0. So now what I need to do is I'm going to plot these 2 points. These are the 2 intercepts. And I'm going to plot these 2 points on my graph and then connect the points, and that's how I generate my graph. And so here's how it works. So on the graphing space, and we can draw the axes anywhere we want. I mean, we can draw the axes on our own scaling. And so we can have something like this. Okay, and so now 0, 4, 0, 10. So 0 for x, 10 for y. So right on the y-axis, you're going to go 2, 4, 6, 8, 10. Right there is my first point. And now the next point is going to be 4, 0. So 4 for x, 0 for y, meaning the point is sitting right on the x-axis and counting out 4 units out. So there is your point. So now you have 2 points. There you have 2 points. This point here is the point 0, 10, and this point here is the point 4, 0. So now we're going to go ahead and connect the points, and we get this kind of line that's passing through the graph. And that's how we graph the equations. So this equation that I just graphed, it's the graph of the equation 5x plus 20 plus 2y equals 20. So that's one basic technique for graphing a linear equation in standard form by plotting the intercepts.